All right, everybody. Good to see you again. Our goal today, as we're continuing to learn about simple machines, is we have to take this extremely heavy pencil. We can think of it as really, really heavy, or we can just think of it as, well, you can't quite see it, or we can think of it as, that it just, we can't lift it up, okay? We can only roll it. That's the only way we can move it. So our goal today is to get this pencil that we can't lift up to the top of the chair. That's our goal. All we can do is roll it. So I want you to go ahead and pause the video in just a few moments and talk about how do you think we can do that? What simple machine do you think could be used for our success today? All right. Today we're going to be focusing on incline planes. What is an incline plane? Well, if you're looking at this book, which all of us do have access to, if you want to read a little bit more, when you're done here, is think of an incline plane like this picture right here as a ramp, something that makes it easier to move the boxes. Now, instead of lifting the boxes in the air and onto the truck, you can just push them up there. Instead, they're actually using two types of simple machines. What do you think the other type of simple machine is in this picture? Yeah, absolutely. It is the wheel and axle. Page 8 here shows you how you can build your own ramp or build your own incline plane if you're interested. I'm going to build my own today too. A ramp you can kind of think of as a kind of like a staircase almost, as a way to go up and get things in the air. All right, before we get started with a little bit more of our creating our incline plane, we want to go over a little math equation here. Work is what you actually have to do to get something to move. And we measure work by taking the force, how much it actually takes, how much energy it actually takes to move something, and we multiply it by the distance. How far do we want to move it? Do we want to move something like this? Do we want to move it a little bit more? Okay? If our force increases, means like we're trying harder, our distance will decrease, so we don't have to push it as far to do the same amount of work. If force decreases, distance will then increase. And this right here, if force decreases, our distance increases, is something that we're really going to be focusing on today when we're making our incline plane. For our scenario here today, we're going to pretend that this marker is laying right here, and our job is to get it up on top of this chair. Now, if I pick this up and set it on the chair, I have only moved it about 40 centimeters. Okay, since I moved it 40 centimeters, I had to use a certain amount of work or a certain amount of effort to pick it up and put it here. If I end up rolling it or pushing it up the inclined plane, I can do that with less effort. But what happens is instead of only traveling 40 centimeters, our marker travels 100 centimeters. So our distance increases, but our effort decreases. We don't have to try as hard to push this up. And you could really kind of think of it as... One other way I like to think of an inclined plane of trying to help is if I'm trying to go, let's say I was trying to get under the roof of the school. There's a couple different ways you could try to do it. You could try to climb up the wall, where a lot of the kids play wall ball, out on the playground, and you'd have to try to climb straight up. That's going to take a lot of effort to get up there. Now, if you had a big giant ramp that you could lay down, that would be up on the ceiling, and then you could just walk, and you'd be able to walk nice and easy up this nice little gentle hill. So think about what would be easier, walking up a little hill or trying to climb straight up a wall. Which one of those is going to require less effort?